Hi, one of the frequent questions that I get asked is what does DevOps actually change in the SDLC? Of course, there are a lot of related questions as well, such as is DevOps just Agile plus plus? Do I have to do Agile to be DevOps? Or if I use tools and automation, does it mean that is DevOps? If my work is primarily ticket driven and SLA driven and I'm following ITIL, then do I really need DevOps, etc. So in the next few minutes, what I wanted to share with you is an approach that I usually recommend for teams that are looking at adopting DevOps ways of thinking and looking at maturing the software lifecycle. I'm saying the software lifecycle and not just the software development lifecycle, because the primary objective of DevOps is to ensure that the full lifecycle of software, from the requirements till the time the requirements becomes usable, is the complete lifecycle, and that is what DevOps is all about. There are 10 big blocks that we can explore. Mapping the current life cycle and looking at these 10 aspects would give us some ideas in terms of what might change, what is it that we want to do in each of these areas, and when they all work together, how the value for the users can be maximized. So to start with, the backlog management, or essentially the management of requirements, is very important, and these requirements need to flow through the full life cycle, and as they get transformed through the life cycle from concept to code, managing the configuration of not only the software elements but also the deployment environment elements becomes important. Now, to orchestrate all these pieces that are getting developed over time, we need a stable architecture. With that, we would be able to adopt what is called as shifting left. The concept of shifting left essentially is to do some of the activities that traditionally are done later in the life cycle to as early as possible. Now, once you do that and you have greater confidence in terms of the quality of the code, we also need to manage the user experience once something is deployed and delivered. So that would also mean the ability to be able to continuously deploy or continuously deliver. We'll explore these in a little more detail as we look at each one of these. And then, of course, the user experience that we need to monitor, analyze, and learn from that through the feedback loops, along with a good governance framework. With these 10 blocks, let us look at each of these in a little more detail. The first is backlog management. Traditionally, we are used to creating requirements in the beginning of the project or when we create a product, and these requirements focus a lot on getting the functional specifications, what are the business requirements, and so on. Some aspects of the non-functional requirements might also be built in for performance critical or security critical, or when there are a lot of regulatory compliances that need to be catered to by the solution. And a little later, we also look at some of the technical requirements or technical constraints, including some of the possibilities because of our choice of technology. Now, when you look at it with a DevOps perspective, you will have all the three types of requirements, that is the functional, technical, and the non-functional requirements, all kind of taken together. Now, another thing to note here is that while I'm talking about this as the first step here, it is not a one-time activity. This backlog needs to be groomed continuously. It will get refined. There will be changes to this as we go along. But the key is you look at the functional requirements, which is going to provide the direct business value. The non-functional requirements, typically what may also be called as the operational or production requirements, that would have a significant influence on the experience of the users, as well as the technical or technology requirements that might give us new ways of doing things or ways to do things in a simpler manner. And sometimes technology also imposes constraints. So the backlog management will include all three aspects, and of course there are various techniques that you can follow, like triaging the requirements of user interviews or creating prototypes to get feedback, etc. But the idea is that your backlog has to be managed with participation from not only the development teams, the business analysts representing users, and the testing teams, but also have the deployment team participate in this. They bring in a lot of value in terms of the deployment requirements, whether it is performance, scalability, stability, security, etc. So this is the first aspect that we need to look at when you look at your life cycle with a DevOps view. The next is to look at the way we normally develop, test, and release to production. Now this will include the full life cycle, starting with development, going on to production, and till it reaches the user and the user can actually experience this. Okay. So all the activities that we do for development, which includes some of the detailed designing, the technical approaches such as test-driven development, or creating unit test cases, automation, and also putting it into production where we might have some staging environments and so on, and finally getting it into the user's hands. So when you look at the full life cycle as a DevOps, with a DevOps perspective, we will need to look at again the considerations from not only the development and testing sides, but also the production aspects that we need to consider. The third aspect is configuration management. Now configuration management, if you look at this diagram, covers not only development but also goes into production. Okay. Now traditionally both development and operations have been following configuration management practices. The CMDB in IT is a very good example of how formalized your configuration management can be. Similarly, development teams also adopt a different configuration management strategies using tools, and the decision taken in terms of whether you do what is called as trunk based development or branch development, how you apply patches, upgrades, and so on, would all be part of your configuration management strategy. One simple rule or a highly recommended good practice among DevOps teams is to do trunk based development. I know it may not be very easy to implement, but with a little bit of discipline and over time you can definitely look at it. Yes, there is an impact on the architecture as well as how we develop. The advantage of trunk based development is that it not only reduces the potential conflicts that take a lot of time to be resolved, but also you know that there is always only one version that is out there. Okay. So if you need to fall back on an earlier version, or if you need to selectively activate, we'll talk about that a little later, this approach is going to be very, very beneficial. Now this configuration management, so far what I spoke about has been on the software development side. This configuration management also needs to extend to take care of what will be needed in the deployment side. Okay. The versions of the environmental software that you have, maybe operating systems, maybe the utilities, maybe libraries, maybe your database versions, and so on and so forth, as well as the hardware configurations at the endpoints. Now, with many of these applications going mobile, the endpoints are not directly controlled, or you may not even know what exactly is the configuration in the hands of the user. So these aspects also need to be considered, and once you have these formalized in terms of your the configuration taxonomy, you'll see that it will have an impact in terms of how you design, how you test, etc. So configuration management is a key practice to have a successful DevOps adoption. The next element is what may be called as architecture. In the diagram, you find that the architecture kind of extends throughout the life cycle. But specifically, when you look at the development, the testing, as well as some of the configuration management here, okay, are all going to be influenced by your architectural strategy. So the recommended practice here is to keep the backlog in small chunks that you take up for development, which means you use small stories, as well as with a model of service orientation. These small stories by themselves will deliver value, but then they can evolve independently, and they may consume services or they may offer services to other stories. So this is a very key element in terms of your architectural thinking, where instead of implementing features, you'll be looking at implementing services. Of course, there are a lot of patterns that we have associated with how you can do this, including the microservices architecture, which is trying to take it to one extreme. Okay. Now, once you've done the architecture, and as you go through, you have a good configuration management practice in place, the next focuses will be on testing. Okay. Again, testing, as you see, extends all the way into production as well. Okay. But as far as possible, if we can do the testing as early in the life cycle, then at least the critical pieces that are developed initially get tested multiple times. That means our confidence in terms of the key pieces, the key functionality, or the critical high value, high risk stories are exercised multiple times, and they will not regress. Okay. So shifting left is the ability to look at a testing activity right from your backlog. Okay. When you define the story, the elements in the backlog, and look at how you are going to test that, which could be the acceptance test criteria, or in the agile world, the approach called the acceptance test driven development. Now that software is tested, we need to deploy. I want to make a subtle distinction between deployment and delivery. We'll talk about delivery as the next aspect. The deployment essentially is to reduce the weight for the developers or the development team to get into a production environment. Okay. Typically, once software is developed and tested independently, and then you go through your system integration testing, system testing, and all that. You might also have a pre-production environment where you may do the staging, and finally this goes into production. Okay. So that is what we mean by deployment with a reduced weight. So even though the software is deployed in production, it may not be available for the users. Okay. What I mean by that is, while there could be code which is on the production systems, you choose when you want to make it available. Okay. Now, this may be done based on a variety of considerations. You may want to turn on features only for a limited set, particularly if you are doing, let's say, A/B testing, selectively trying to analyze how two different options or three different options perform. Or it could be, say, based on a date, which again is a shifting time zone across the globe, and you may want to turn on this feature at a particular time in each of the local time zones. Or there could be a variety of other reasons why you want to uh, have code in production but still not make it available to the users all the time. So that is what we call as continuous delivery. And in order to do that, usually while you have automated deployment, the continuous delivery part invariably has a manual step. There is a decision to be taken in terms of when do I want to make this available to everyone. Now, once you have delivered it to users, we need to monitor the user experience. Okay. Now, the user experience monitoring happens in two parts. One, which is the inside out view, and then we have also the outside in view. Okay. Now, the inside out view would be in terms of how quickly we delivered, what is the uptime, what is the response time, and all that. The outside in view would be things like what is the response to the A/B testing, has this really created an impact, whatever metrics we want to have. Now, some of these are direct measures and some of these are indirect measures. So when you look at DevOps, one of the key aspects is what is called as log analysis. Looking at not only your production logs, which may be available from servers and other layers that you use, but also you might build in some amount of analytics code or logging code in your applications. Okay. And once you have a lot of data, you need to be able to analyze and make sense of that. So typically the monitoring the user experience is about how our software is performing under live conditions and what is the user experience, is it meeting our goals. With all this, the moment we get into analytics and reviews and all that, we nicely get into governance. Now, governance is all about enabling the teams to be responsive to users, which means that irrespective of what methodology or approach they use, which is say a combination of Scrum and Kanban, maybe a Scrumban, or the extreme programming practices on the development side, the approach of something like Scrumban would help us bridge some of the cadence differences between a dev, which probably is more comfortable with Scrum, and the operations, which may be more comfortable with a Kanban kind of an approach. But the key is to create an operational cadence between development and operations teams, and that is best achieved by having some shared KPIs. Okay. In addition, since we are talking about delivering value to users and monitoring that continuously, it is also to ensure that while there are frequent deployments, while there is a lot of seeming volatility in the software, that security and performance are not compromised. And of course, in case there are issues, how can the systems quickly recover? Call as resilience. And while doing all this, obviously, there are something that we need to consider from the outside in perspective, how satisfied are our customers, and from an inside out perspective, how quickly are we delivering, how much waste are we reducing, are we creating solutions, are we delivering things that matter to our users more, and all these would be aspects of governance. And lastly, when we do all this and when we have our tracking and monitoring and planning and all those systems in place, the experience from production, the experience of actual users, the impact on business is something that has to come back all the way to our requirements. First, to validate that whatever requirements we took up was something that was useful, or if we find some surprises, if we find some variations, or if we find that users are now demanding more because they are able to do things that they were not able to do before, those would also have to go in as either functional requirements or sometimes possibly non-functional requirements when, say, availability and access become issues. Now with all that, the whole loop starts again. So this, in a very brief nutshell, is the impact of DevOps thinking on your software lifecycle. You will be doing all the activities pretty much the way you were doing, except that there are some of these good practices that you may want to adopt in each of these phases. There are these aspects that would have to be taken into account together in order to deliver a user experience that will be satisfying and rewarding for business. Thank you for your patient listening. In case you have questions, you can reach me at sivaguru@pmpowerconsulting.com. Thank you and all the best.